Hey guys, in the last video, we covered setting up the development environment. We set up the Anaconda and then we ran through examples running on the local machine. And now we are ready for the next step. Today, we are going to cover some of the very basic theory and also some mathematical background, how the linear regression that works. We will be exploring different forms and how the graph work and then plot the data using some examples here. All right, let's start. So if you see what is the linear regression, I am sure all of us, we have learned about the linear regression in high school and college, but just a quick review one more time. It's a statistical method used to model the relationship between a dependent variable and a single independent variable. There could be different form and there are a lot of examples. One very easy and intuitive example could be the house prices. Uh, we generally, whenever the house size is bigger, its price is more. So based on the square footage of the house, the value of the house, its price is more. So that's one relationship there. That's an example of the positive relationship, but similarly, there could be a relationship between number of cylinders in a vehicle and the number of miles per gallon it covers here. Let's look at both examples in the form of graph. So for example, if we see the first one, variable x, that is the independent variable that shows the square footage of the house, and y, that is the deterministic value, that's like the predicted value, that's the base of the house. And the red line here that shows the regression line, and these are the different data points. Uh, these graphs and the data values, they are not like really perfect. It doesn't like it doesn't have to go and match every single value, but at least it gives you a very high overview. That's where the purpose of the this is an example where we are using only one variable x, only one parameter here. And this is an example of positive regression where value of x increase, value of y is also increasing that. There could be some other variation of that one. Just for sake of completion, I will cover one more example where instead of showing the positive, we'll show negative relationship here. If you see the vehicles, the number of cylinders, like 4-cylinder, 6-cylinder, the way for the bigger vehicles, more number of vehicles, more number of cylinders are being added. You will see the gas mileage usually go down. If you have 4-cylinder, it could go like maybe 25, 30 or something like that. But if you are like 6-cylinder, 8-cylinder, 10, it will keep going down and the gas consumption will be more. So that shows a negative relationship there. So it could be positive or negative. But one thing common between both of these graphs, that both of them, they are relying on one single variable. That's why we call it one variable regression. There could be, if we can enhance this example, and instead of relying on one single variable, we can go and add more and more variables to make it more meaningful. Let's see. So multivariable regression model, that relationship between a dependent variable y and two or more independent variable x1, x2, that kind of stuff. So if we continue the example of house prices, last time in the last graph, we saw the square footage of the house that is determining or predicting the value of the house. But if you add more variables to it, like for example, its location or maybe number of the bedrooms or some other similar variables, if you keep adding, then based on those variables also, you will see the value of y will be changing there. Uh, let's see furthermore. So if you see this graph, variable x1, variable x2, these are the values. Let's say the number of bedrooms and number of the square footage, and the y, that is the other variable which is dependent on x1, x2. That value will be changing, and this graph shows you how the vol values are plotted there. Um, I know in the beginning I told we are going to cover more and more the coding effort, but we are going into an area where some of the mathematical background is required. So we need to have a quick understanding of how these math formulas are working. So this is the the math formula for linear regression with one variable. So y, that is the dependent variable, thus like actual value which we are calculating, it depends on x right here. So x is the independent variable that will keep changing, and b naught, that is the intercepted, the predicted value of y when x is 0. So x will be multiplying with b1, and then b naught, that will be the slope there. Yeah, so we will see different example, but the point here is if x is 0, b1 times x will be 0, and the remaining will be b naught only. One interesting thing is it really depends on the domain. Not necessarily every single time x could be only positive or negative. It really depends on the domain. If you see the house prices example, you will never see a house with negative square footage. So maximum it could go to 0. So once it go to 0, b1 times x will be 0. So remaining b naught plus error function will be determining the value for y. E is the error term. We will have a separate video how error functions are calculated and how to tune up to make it like overfitting or underfitting and those kind of stuff. We will explore more on this one. For now, we can park this item. So this formula that covers only one variable, but if you want to include multiple variables, concept is still same. It is just that instead of one, you'll say b naught plus b1 x1, b2 x2, and then continue with as number of parameters you have there. All right, so that was all the theory. We were just looking how these calculations are done. Now we'll see the working examples. To explain more, I have created a sample code in Python, and I also put that into a Git location. Let me bring the location here. So this is a Git project. If you go to AIML beginner, under that one you'll see a directory called Linear Regression. Under that one, there's an example, regression examples right here. And this example is going to cover the single and multiple variable regression. All right, so if you have already cloned this location, well and good. Otherwise, just click on code, go to HTTPS, copy this location. All right, and then we can go here. You can use terminal or any of the windows if you have installed any client, but usually I use bash. You just go here, and this command is pretty straightforward. Say git clone, and then give the name of the repository, and it is going to download all the code into your local machine. All right, this is done. It's great. Okay, this whole code is there, and primarily we are interested in this example, so we will look into this in a second here. Okay, so next step is we are going to launch Jupyter Lab. Before that, let me go to Anaconda PowerShell. Okay, by default, it is pointing to the environment base. We are going to change the environment to the sample environment we created in the last lab. So I'll just go and say conda activate and env environment scratch. Okay, you see the name of the environment is changed from base to environment scratch. That is good. Now we can say Python data version. All right, it looks all good. Now we can say before we start the Jupyter Lab, we can move to this particular location. Okay, Lab, and it is going to launch Jupyter Lab into a browser. It's running a local web server, and then it will also open the directory, the current directory where the files are loaded. All right, great. So it is working. So right here, let me show it to you. Starts. Okay, so this is the launchpad. We do have a terminal here. Very quickly, you can go and just That is good. All right, this is working great, and it's ready for execution. Cool. Okay, open example, regression examples. All right, so I have created a sample code by using standard NumPy and Matplot libraries. And there are two sections of this example. First section is linear regression with one variable. I'm just doing the random house sizes. That's the only variable here. And then calculating the house prices, and we'll do the predict the value, and then we will plot these values as a graph just to represent how these values work here. This is an example where only one variable, house size, is being used. Then in the second part, we are going to enhance this example by adding one more variable. So in addition to house sizes, we are also going to add the bedrooms here. So within the sample, you will see now two variables, house size and bedrooms, and then we'll see how the graphs look into it. So the expectation is it is going to generate two graphs, and then we will compare both of them one by one. Okay, I think I can just go ahead and run all cells in one shot. All right, this is done. Let's quickly look into both of them. So if you see the first output, this is the display for, if you see at the top, this is simple linear regression, house size versus price, one variable. So this is independent variable, house size, and the price is the predicted value, and this shows the graph right. So only one variable is all. Now, if you see the second example right here, and it says multiple regression data, it shows the number of bedrooms as well as the house size, and both of them collectively predicting the value of the price, which is shown into the y-axis. The lower graph, if you see, it's more intuitive. You see, like similar to x1, x2. So x1 is house size, x2 is the number of bedrooms, and the y, that is on the y-axis, the price, that is the actual predicted value. That was a quick overview. We just look into some of the base math involved and examples how regression work. Going forward in the next examples, we'll continue to build more and more into the regression model and create more examples into that. Thank you very much.